Welcome to Cpp.chat, a proxy iterator onto what's going on in the world of C++, chatting with guests from the community. Now, before we build up to this week's guest, John has some disclaiming to do.
All right. So this disclaimer actually has a disclaimer. If you Google disclaimer Pitchfork, you will find this. And I'm going to have to edit it because apparently there's an age rating on this podcast. So this is actually lyrics. Random disclaimer. Hey, don't do anything I say in this song, okay? It's effing fiction. If anything happens, don't effing blame me, white America. If you want to know the source of that, just Google disclaimer Pitchfork, and the top thing that comes up is an article about this lyrics of this song. So anyway, we have what's likely to be a very, very fun show today. Just found out that Michael Case is in the audience, so yeah, it's going to be a fun show. Anyway, what I forgot to say last episode, and so I'm going to do this first. I have to censor this because I have the damn book, which is what John Lakos calls it, because as you notice, the cover of it has a damn on it. So he calls it the damn book. Anyway, I have it in-house. Needless to say, I've already read it. There's lots and lots of notes I've taken in it. You just can't see them. Anyway, I actually am excited. This is the most eagerly awaited book in the C++ community for the last, I think, 10 years or maybe even longer.
Closer to 20, I think.
It could be, yeah. This book has been in the works for a very long time. Anyway, speaking of longtime mysteries, there's this guy that sometimes posts and says some kind of interesting things. And his name is vectorofbool. And he never actually says what his real name is. This is crazy. We know him as vectorofbool, but we don't know who he really is. So not only is this a mystery in the C++ community that we're just about to reveal, it's also a pet peeve of mine because I have long time said we are a professional community. We're not a bunch of gamers. This isn't some weird sexual cult where we have to hide our identities. This is how we make our money. This is a profession, and professionals sign their work. So we don't use clever things like Phil squared or something like that. We sign our names. So welcome to the show, Vector. You want to tell us what your real name is?
Hello, my name is Colby Pike. I used to use my real name on Slack, but I don't know why. I don't even remember why I switched it back. So I'm vectorofbool.
Maybe you thought you'd be more efficient.
You might have been more efficient. Yeah, it was space saving, right?
That's the idea. That's the hope.
Yeah. So no, but the reason I say this is because if you were to come and speak at a conference and you were to say, hey, Colby Pike is speaking for the first time. Well, who the heck's that? But they said, hey, vectorofbool is speaking. It's like, oh, yeah, I've read what that guy says. And that's what I'm saying is because when you come and speak, we're not going to say you're vectorofbool, although we may have to put that in parentheses or something because it's your name and that's who you are. And you should associate your work with your name. So this is my pet peeve. And everybody says, okay, boomer. And then they go on, right? So anyway, so where have you posted with that name? Where have you made that name famous?
I have a blog under that name. I write a lot of Reddit comments under that name.
Okay.
I tweet under that name. That's my GitHub username.
Yeah.
In some places, I do use my real name in copyright disclaimers, I think.
Yeah.
But that's most of my online presence.
Yeah.
Oh, I have a YouTube channel that I haven't posted to in too long with that name as well. There you could have seen my name if you look at the name of the home directory that I use.
I see.
So it's not a complete secret. But
so you're not exactly hiding from the law.
Yeah.
Do people ask you what the heck is vectorofbool? Or do people know? Does everybody know what that means? What the significance of that is?
Most people in the programming community understand it. C++, I've never gotten a question from a C++ dev, but some people who see it from outside just aren't quite sure what that means.
I see.
But Yeah.
Okay. Does other people give you grief for this, or is it just me?
You're the first so far.
Okay, great. All right. Well, you can just say, okay, boomer, and drive on.
Mhm.
But I would like to hear how you explain it to a layperson.
I'll just say, I usually just say it's a programming concept, or I'll send them a link to the CPP reference page with the big note section that says, here's all the things that go wrong when you put bool here.
That's cruel.
Yeah, that's even more cruel.
Mm-hmm.
Just tell me, you'll understand when you get older. All right. So yeah, let's talk a little bit about. Well, do we have news before we get into Pitchfork?
We have a little bit of news.
Okay.
I think we probably mentioned last time, maybe even the time before, most conferences have been cancelled. So we're not going to do a big long list of those. But quite a few have been moving online. I can't remember how many we mentioned before, but C++ Russia has moved online. It's going to be end of June, beginning of July, I forget now. Italian C++, that's also moving online again in June. And as of this week, in fact, I'm pretty much breaking the news here now, C++ on C is moving online. That's also going to be moving back to July. So I did publish a news post last night, but I haven't really published that anywhere else yet. So I'm going to do that shortly afterwards, but I'll put that in the show notes. And also ACCU Belfast was cancelled completely. We may have mentioned that last time. And Microsoft had an online conference, the Pure Virtual C++ conference. The videos for that are already out. So
a little birdie told me, and I don't know if this is at all secret. I wasn't able to watch any of them, so I wasn't there. But apparently, I'm in the minority because they had huge numbers that actually were tuning in live. This is one of the things that I know that in talking about conferences, one of the things that we've talked about doing is, well, maybe we should stream the keynote live. Maybe we should do something special, and maybe we should do some things live. And I talked to, Mark Bashan, who runs Bash Films, who does all the recording for both CPPCon, C++ Now. He also does the recording for LLVM conference. He told me that he had done this live at a Linux conference where they really, really wanted to have a live presence. And he said they spent a huge amount of money and they got a very small turnout. He said it would have cost less to send airline tickets to everyone who was listening live. It was that disparity between the number of people who, of course, that wasn't during the pandemic, right? I mean, this was years ago. The thing is that given a choice between watching live and watching a recording where I can stop it, where I can back it up, where I can speed it up if I want, all these things, turns out the recording generally is better than live. It's not an announcement. It's not like I'm announcing the NBA draft or something like that. There's no suspense. I'm giving a talk and you want to stop and back it. So that makes sense. And so the idea of doing conferences live is something that I've thought about and pretty much said, it's just not worth it. Why watch it live when you can watch a recording, and what's the point? But Microsoft said, well, the pandemic, we're going to try it because we've got message we want to get out. We want to talk about C++. They did it and they got over 1,000 viewers live watching the event. So I don't know. It's causing me to rethink a little bit about what's possible, what makes sense. The big question, of course, is this the kind of thing that would happen again after the pandemic's over? When people are commuting to work and they're at work and there's all this stuff going on, are they going to be able to tune in live, or is that something that makes more sense when you're working from home? Who knows? But it's very interesting and kind of exciting to know that the community was that interested to watch live with that kind of numbers.
Yeah, it's definitely making us all rethink a lot of our assumptions. And as you say, many of them won't continue to hold when this is all over, but we're going to be living in a new world, so we're going to have to reevaluate those assumptions anyway. Yeah. I've definitely given this a lot of thought. I was also in the camp that I wasn't sure an online conference could really work. It certainly wouldn't work in the same way. No. So I've been doing a lot of experimenting. Well, we've done one so far. Yeah. C++ London meetup online, but that went really well. Some experimental aspects to that, including having a separate video conferencing rooms for the attendees as well as a broadcast of the speaker, and that seemed to go quite well. Some more ideas to put into the mix next time as well. So we're going to keep iterating that. Which actually leads me on to mention that a lot of meetups in our community are moving online. So many that it wouldn't be possible for me to list them here now. But you don't need to, because someone's already done the work. So Harold from the Sweden C++ group has put a feed that he's picking up from meetup.com directly on their website that I'll put a link to on the Sweden Cpp.se site of all the upcoming virtual meetups in the C++ community. And now we can travel to any of them because we don't have travel time, just time zones to worry about.
Yeah, and this is definitely, I mean, I'm constantly asking myself, what's the world going to be like after we return to normal? And I would love to see one or maybe a few virtual user groups where people are not, all a user group by now, they always are synonymous with local user group, right? Because the whole point is you go and you do face-to-face, and that restricts you to kind of local. And that, I think that should continue. I think face-to-face is wonderful. I mean, I would really like to actually, shake the hand of a C++ programmer at some point in the future, or at least bump fists, which is the way I usually do it. That would be great to return to that. But it's also, there's room, I think, for people who are very remote or afraid of crowds or afraid of germs or whatever the reason. I would love to see an option for them as well. And that'd be sweet.
Yeah, for all of us that hide behind usernames.
For all of us to hide behind usernames, that's right. I want to get you a sticker that says, "Hello, my name is vectorofbool."
Mm-hmm.
All right. So there's one other announcement, and that's in the tools camp, at least one of them that I know of. Are there others? GCC 10.1. Did you know some about this, Colby?
I've been sort of eagerly awaiting GCC 10 because I know it's going to be like the first compiler with full concepts and constraints all done, and this is one of the big C++ 20 features that I'm really excited about, maybe more than any other. I mean, they've been shipping the concepts TS for a long time, and I've been using it since GCC 8, which has a whole bunch of asterisks on it of things that is slightly different, but they're now shipping it. And
you mean slightly different from the standard is what you're saying?
Yeah, so slightly different.
It's not a perfect implementation of the standard in 8.
Right. Yeah, there are certain differences, and now I'm really excited to see that finally available. They have const per new. They have their experimental coroutine support with behind a flag, and a whole bunch of other smaller C++ 20 features. So I think this puts them close to, or if not the furthest ahead in terms of modern standard implementations. So that's great advancement. I'm excited to be able to try it out and use it.
And 2020 is not even over yet.
Yeah, it's not even over. I mean, we'll probably have a while until modules become available in any compilers, but that one's quite a big change compared to anything else. So wait and see.
All right. So you've been playing with concepts for a while. What's your feeling?
So I've been playing a lot with concepts TS that was shipping in GCC 10 because I'm trying to not in GCC 10 but in GCC 9, which is missing some of the niceties like abbreviated syntax, but I'm really enjoying it. The error messages are markedly improved. They're still large, but they're actually understandable. It can say that this here is where you had a constraint failure and not someone made a semantic error like 4 miles away, and you have to sort of work your way back to find out what's going on. And I'm even more, and not a lot of people discuss it as much, but the effects it has on overload resolution, where I can define two template functions, or even two class templates rather, and I can say I can give them different constraints so that they look like they're they're the similar enough overload, but now I can say this one is more efficient or behaves slightly differently depending on the semantic, or rather the syntactic properties of the types of arguments that you've given it. And that's something I really am excited for concepts.
So can you give us a specific example of what you mean by that?
Yeah, so one example I've been working on recently is a library that does data compression, and you have to give it two arguments. You have to give it some input, and you have to give it some output, and it'll just take the scratch, or it'll compress the input and write it into the output. Now, there's a no allocating version which will compress as much as it can into the output. There's an allocating version which will compress all of the input and dynamically resize the output as it goes. And so the two functions look the same, but depending on the type of the output argument, it could be either a dynamically sized buffer or a fixed size buffer. And I can have two completely different implementations that both behave intuitively, and they at the call site they look the same, and you can understand what's happening at the call site. So you don't have two different functions to call. It's just one in a single overload set.
And the point is that the decision is not made by the caller, but by the callee. The callee looks at the types of the arguments and says, oh, look, I can do something different here because of this type.
Yes. Yes-ish. I mean, the caller still has the choice, right? If they hand you a dynamic buffer, then they know that the semantics of that is, okay, grow the output to fit all the compressed input versus put as much as you can in there until you run out of room. So this, and of course, by the way it is implemented, it's that the dynamic version calls the fixed version that doesn't allocate. So we can define overload sets that have more expressiveness, I guess is the best word.
Mm-hmm.
So that's probably the big feature that I'm excited about.
That's overloading on properties of the type rather than the full type.
Yeah, overloading on the semantic and syntactic properties. Well, you can't really overload on semantics yet because concepts don't express that as yet, and we're not sure if we're able to do that. But overloading on properties of a type is the best way to put it, rather than the name of the type.
Right.
And
well, essentially, a programming language is finding a way of expressing semantics in syntax, right? I mean, that's what a programming language means.
Right.
Neither the compiler or the interpreter can actually understand semantics. All it can do is understand syntax, and so that's what we're trying to do. So, so you're essentially saying a little bit more of the semantics is expressible in the syntax, essentially.
Yeah.
Because of this type. Okay. All right. Are those the kinds of things that you talk about on your blog?
I haven't posted anything about concepts yet, although I've thought about it. I might have some interesting things to write, but nothing concrete yet. Most of my posts of recent have been all about modules, since that's a hot button issue.
Well, it's another huge feature of 20.
Right.
You want to talk about what you've been writing there?
Sure. Mine's mostly. I wrote a post back in earlier 2019, a little over a year ago, about like SG15, the tooling study group. They were sort of having this really strong concern over the toolability of modules, and I wrote a post about this, and it kind of took off a lot harder than I expected.
It's because of the clickbait title.
Right. It was.
What was your clickbait title?
The post was C++ modules might be dead on arrival. Oh no! I mean, that's pretty clickbaity.
Yeah, it is.
And it did better than I expected. It got quite a bit of circulation across all the tech sites, and it did get some work started on SG15, and eventually led to the work being done on the a technical report out of the group that should help.
Okay, so what was your issue? What's your concern, and what was the what did it respond? What was the response?
The concern that not just I had, but a whole slew of people, most of them from SG15, was over sort of incongruity between the way modules was being specified and the way tools currently operate. It seemed there was a lot of misunderstanding on how build systems actually process source code, and we wanted to make sure that modules was designed in a way that they would be possible to implement tools that behaved or performed in any reasonable speed on those, because it adds features to the language that mean build system will have to actually look at the code in order to know how to build the code, which is unprecedented in the C and C++ world.
Well, except we kind of have that now, right? I mean, they look to see what the includes are. But that's a really limited syntax, and it maps directly to a physical world, right? I mean, there's a path.
It doesn't. Well, actually, a lot of build tools these days don't actually look at includes.
Okay.
Like Ninja, a popular build one, as well as Make, when it's generated by actually Make does this, Ninja does this, MS Build also does this. Is they basically watch the compiler execute and ask it which files it opened on its way through, and then it scribbles down that result in a persistent database, and it's able to look up that reference after the fact in order to know.
Do compilers have an API to report what they're opening, or are they actually like spying on the file system at the OS level?
So GCC and Clang both have one. It's the -big M flags. There's a whole set of them that tell it to write down like a tiny little make file that is says what the object file name is, and then every file that it read as it went through compiling that object file. Whereas MSVC.
Now wait. I'm still not on board here yet.
Yeah.
How does this work? Does the tool run the compiler once and then run it again for real? Would the big M just says scan? Or, I mean, how does this actually work?
So the first time that the tool...
I'm sorry, I'm getting in the weeds, but I'm really curious about this, and I don't know how it works, and it's a mystery to me.
So the first time that the build tool needs to run a compilation, there is no object file at all. So it doesn't really matter what the inputs to the file are. It knows it needs to compile it. So when it compiles it, it asks it at the same time, while you're compiling, keep track of what files you've read and write them down over here. And then in subsequent invocations, it knows what files went into it in the first place.
So does somehow the build system map that big M file, or whatever you call the file, that -big M file, is that somehow mapped to the particular object file?
Yes. So the -big M will write a make file syntax, and GCC or Clang will write a tiny little make file that is just an object file, and it's the files that went into it.
That file is itself an object file?
No, that's a make file syntax. It's a plain text file.
Okay. All right. And so that's how things really work now. And that doesn't work in a... Well, the compiler doesn't know what file to open, right? I mean, so if you say, oh, import this module, compiler doesn't know what the file name is, right?
Correct. So if you say import A in a file, there needs to be some way the compiler can know how to look up the interface of A. And that's still sort of a floating question of how that happens.
The standard is being voted on now, but we still don't know how it works.
Yeah. Well, I mean, there's different implementations in different compilers that all behave slightly differently. The general rule, well, there's ideas of mappings, like one file that says here's module name and here's the file that defines it. So the standard does not mandate that there actually be an intermediate file. So if A imports B, then there's no requirement that there be like an intermediate compilation of B. So it could be that the compiler just goes and finds a B module somewhere and just reads it plain text. That would give you probably not a lot of benefit over include files, since since they would still have to do the whole lexicon scanning and parsing of every file that you import. The hope is that modules, because of the way they provide source code isolation, it'll be easier to generate reliable pre-compilations of these modules, so the compiler can easily pull in the interface of a module without having to reparse the entire thing every time. But in order to generate that sort of pre-compiled module, which is we've termed the compiled module interface, or CMI, previously known as the BMI, but if we want that speed up, we have to generate that compiled module interface before we can actually compile any other translation units that might import that module. So since we can't know ahead of time what modules it'll import without actually scanning the source file that does the import, we have to implement some sort of scanning phase. And different compilers have been working on their implementations of a pre-scanner that does this module import scanning as fast as possible, because we don't want to do a full parse of the entire C++ source code just to build this map of who imports who, because that would probably double the compile times rather than actually shorten them. So that's where we're looking at now.
It seems to me, I mean, I can't see any solution to this except that you accept some kind of undocumented, or at least not in the standard protocol. Somehow we say, oh, if you're looking for a module with this name, then it's going to be in a file with this name, or it's, I mean, and the idea that, do we just expect all the tool vendors to come up with their own, whatever the way, or do we expect the tool vendors to get together and discuss it outside the standard? This is, okay. So what has SG15 said about this? SG15 is the standards study group for tooling.
Well, pretty much what you just cited as worries is exactly what SG15 was worried about. That led to the initial concerns and led to that post. But
so are you serving on 15? I should ask you that. Or are you just looking over their shoulder and making their lives difficult?
Mostly looking over the shoulder, although I hope I'm not making their lives difficult.
That's why you use an assumed name, right?
Right. I haven't been very closely affiliated with any of their work for a while, but the technical report they're hoping to produce basically addresses all of the concerns you just noted, which is there will be some standard way that tools will interact, and it won't be part of the proper language or library standard, because tools inevitably want to move a lot faster than the language can. So we need a technical report that exists outside of the ISO full ISO standard process. So it's not going to be like an ISO standard. It'll be a technical report document, which we can update more rapidly as tools evolve, as compilers evolve.
Oh, that makes sense to me. We usually think of the language in terms of, well, there's the code language and there's the library, but the truth is there's really this other dimension of tooling, which
right.
if language and library are properly specified, supposedly the tooling, you can portably work with any tooling, but in practice, there is this other dimension of you're running on a particular file system with a particular ABI, all these kinds of things, and somehow you either standardize them or you don't standardize them. And if you don't standardize them, then that means that different compilers on the same platform can't share object files. And if you do standardize them, then somebody has to do that, whether it's the OS vendor or the chip vendor, or somebody has to define what these standards are. And
right. Yeah.
So I think the idea is that although the this report is not part of the standard, so you can still be conformant and not follow it. In general, you're expected to follow it unless you have a good reason not to. And you may do, because we can't cover all platforms and all tooling environments needs 100%, but most of them should be able to follow certain conventions that are going to make the whole thing a lot easier.
Right. And it would mean that you couldn't say that someone wasn't ISO C++ compatible just because they used a different way of trying to solve these problems, because it's not part of the official standard. But it allows, one of the issues we have is that theoretically competing tools shouldn't be talking to each other at all. That's antitrust violations and all sorts of crap. And so that's what we have the standards committee for. It's so that people who are literally competing with each other can still get together and talk. And supposedly it's in a way that's, instead of being out to disadvantage the consumer, but actually to better serve the consumer. At least that's the whole theory of this.
And it works.
Well, so far it's worked pretty well.
For the most part.
For the most part. There are people who are critical. I haven't actually met any personally, but there are people who are critical of the process. And if you are critical of the process, please write to me. We'll have you on the show. Anyway, so let's talk about Pitchfork. What the heck is Pitchfork?
So the story behind the name, at least, it started as a Reddit post forever and a day ago, at least 2 years now, because the document hasn't been changed and modified heavily in over 2 years. But it started as a Reddit post that prepare thy pitchforks, because there's certain topics you don't talk about without expecting the angry mob to form and come burst through your front door. And
I thought we weren't going to talk about East Const on this show.
Mm-hmm. Yeah, that's one of those spaces versus tab, Vim, Emacs, all that. And project layout is one of those things that, there's obviously the correct way. It's the way I do it. But
it's the way John does it.
I was expecting a lot more pitchforks, as you would say. People like, no, this just doesn't work. But that wasn't really what I found. And it was all about the layout of a typical C++ project, as in the file system structure of the project itself, starting from the root. So like where you place your source files relative to each other, what the names of the directories are, and things like that. And it started out pretty simple with a few little directories, but it sort of expanded there to add more features. I think there was 3 Reddit posts until I had like a full document that outlined quite a bit of details, and it's publicly browsable, and it's semi-formal wording, like as formal as I can without being pedantic, I guess.
Yeah.
But
so it's a set of it's advisory, but it tells you how to lay out a project file on disk, or I should say a file, a project, a set of files on disk.
Right.
This is one of the things, and it's absolutely terrific that C++ doesn't mandate this, right? That C++ should be able to work no matter how you lay out your files. However, to someone who's beginning and they're saying, well, I don't have a preference. Tell me, you're the expert in C++. Tell me how I should be laying out my files. And I see this all the time. I'm installing software, some Unix piece of software, and they say, well, you put it wherever you want. Well, where should I want? You tell me where, and I'm glad that you're not mandating. I'm glad that you're saying you can put it wherever you want, and then you put a path to it right here. But it's better if we kind of all decide, okay, this is a good layout. Somebody thinks it through and says there's advantages to this to do this layout. And that's what Pitchfork's trying to do.
Right. And there's different levels of prescriptiveness. So at the top level, I don't know if you've looked at the document itself. At the top level, you have several directories like src for source. There was some bike shedding over whether that should be src or the word source spelled out, or you with a capital S spelled out, or something else. There's an include directory that's also optional. But once you go inside of either source or include, then there's a different kind of provisions, which are basically how you should relate the namespace structure of the project to the file system structure of the project, right? So every library in Boost is in a subdirectory called Boost, for example, and a lot of them you can step into subdirectories. So you have Boost / ASIO / TCP / whatever you got, and there's a namespace structure there, and the namespace structure closely resembles the structure of the directories that you would get to include those things. There's also provisions over whether you put the header file adjacent to the source file for which it corresponds, or whether you put your headers in a directory called include at the top level, and then you have a parallel directory called src to put the sources in, and their relative paths from those directories should resolve to the same-ish relative path. So this also borrows some stuff from John Lycos' original book, which you mentioned earlier in the show with his new edition, over physical versus logical layouts and what constitutes a component. And I'd answer questions about like what's a submodule, because that's not a thing in C++. It's not even a thing in the C++ modules specification. There's no such thing as submodules. But I couldn't use the word module to describe a directory with a module in it because that would sort of overlap with the terminology used in the standard.
Mm-hmm.
Then what's a package, what's a project, and whatnot. So yeah. There's also some contention over whether the top level src or include directory should even be needed, because I've seen people both online as well as in real life, coworkers, give me grief over like why should I put this here? Why don't I just put the source files right at the top level?
Mm-hmm.
And I do have reasons. It's more it adds a level of indirection that really assists in terms of tooling. So for example, when I need to set the include directory, the include search path on a build system, I know exactly where that is rooted. So I can say right here on src and right here on include, search from here. And that gives you one unambiguous location, and someone browsing the file system can easily see, okay, here's the path to that file. I can just hash include relative to this include directory. So it sets a good place to consider the actual root of the sources, and it's even called a source root. Oh, it's called a source root in DDS. That's not part of Pitchfork specifically.
So what is Pitchfork? Is it, as it looks like there's code here, so it's not just a set of prescriptions. It's a tool as well. It's a tool in a library.
I was working a while ago. I was working on a tool to go along with the spec document, which would let you manipulate and query these source directories or these project directories that conform to this layout, as well as like a quick start. Like you could say pf new, and it would just spit out a new project structure. After, I don't know, 2 years of yak shaving, I'm writing my own build system. So that's kind of how I got where I am today. So I guess everything I'm currently working on is just yak shaving to get back to Pitchfork eventually.
Tooling to support the original Pitchfork proposal.
So
Right.
you mentioned DDS. What is DDS?
the little live indicator.
And I believe we're back on air. Yep, we're on.
All right. I'm not sure where we lost you. Colby, can you reconstruct what you were talking about? You were talking about DDS build.
Yes. I like Michael's case. Why do I have an SRC directory? It's because we are not monsters. That's probably the best, most concise answer. The answer for DDS, it's supposed to be a zero configuration build tool. It's you run it. You don't need to run the configure step like you do with other build tools. So it doesn't do any platform or feature detection. It relies on the project doing that all on its own. And I mean, with the advent of things like has include preprocessor directives, we've made exciting strides in terms of being able to do that reliably. So whereas old build tools, or rather I'd say auto tools, well, I think we're all familiar with the /configure make scenario where you say .configure and then auto tools checks the presence of 700 headers, half of which have been universal since 1978. So now that we have things like has include, we can ask that question at compile time rather than having to ahead of time make that determination in sort of a best guess platform specific way. It specifically is built based on project layout, so the way you structure your source files is significant. It uses the Pitchfork layout with some additional provisions and tweaks. The idea is that it's aimed particularly at library authors, although it has some capabilities of building applications as well. And it also includes functionality for resolving, downloading, and building dependencies, as well as including them into other projects. So it's kind of a hybrid between a build system and a package manager. And one of its primary goals is also to play nice in others' build systems. So there's support for using it from CMake. So if you have a project that is DDS, you can use that project from a CMake project without any hassle. And a lot of this relies on recent advances that have only been made in the past few years, especially with the CMake 3 and later that have changed. So
that makes it easier to support to support being a CMake entity that CMake can understand what you're trying to do.
Somewhat, yeah. So the file formats that it emits, CMake has features that it's able to consume them more easily than it would have in the past. And it's not specifically CMake that it targets. DDS doesn't mention CMake anywhere in its source code. It's the files that it emits are able to be parsed by a very small CMake script shim. So it's seamless from the outside, but some stitching in the middle that glues them together.
This shim, is that something that comes with CMake or comes with, I don't understand.
It doesn't come with CMake, although my ultimate hope is that it would. And the shim itself doesn't even mention DDS, so the DDS itself spits out an intermediate file format that is specific to neither DDS nor CMake, which describes how you can consume a library. And there's a CMake module I've written that is able to import that representation and expose them as imported targets. My ultimate hope is that it would be successful enough that it would be shipped as part of CMake standard, but it's still a work in progress.
All right. So one of the things you might expect me to ask is, have you talked about anything like this at any conferences?
I haven't given any conference presentations yet. I've been I've been to CPPCon 2016, and I intended to go to C++ Now 2020, but we're not quite in a place to have any conferences right now.
Yeah.
Maybe
Tell
if
me
we're
about it.
lucky, maybe I'll get to CPPCon 2020, but fingers are crossed.
All right. By the way, submissions are open. So if you wanted to do a talk on Pitchfork, now would be the time to make that kind of submission. I'm just
Yeah.
pointing that out.
I was thinking about doing presentations for C++ Now, but maybe I'll submit for CPPCon. See what comes from that.
Do it. Now everybody knows your name.
That's right. Everybody knows your name. You'd said something about that you actually can detect the existence of tests and run tests. Is that?
Oh, yes. So Pitchfork includes a provision on test placement. That's this subsection. Big explosion or something yesterday. I'm wondering if they're interrupting service.
I think we should be back.
All right. We were talking about tests, and you said that you did a poll and you found two popular options.
Yeah. I don't remember if it was two. It was a few. Like, there were a few popular responses, and then like one or two very unpopular ones. And I decided to put in the unpopular one, and it caused a lot of hubbub amongst people. And it's actually based on the choice from John Legos' book, is to put the unit test of a component adjacent to the source code of that component itself, and give it the same file name stem, but put a .t. In Pitchfork it's .test, but in Legos' book he uses .t, .cpp as the file name.
I often use .tests.
Yeah. So DDS will find files named .test.c or .test.cpp, and it will compile that into a test executable and execute it when the build finishes. That lets it separate it out, so it knows, okay, if it doesn't have a .test, it's a source file that should be part of the library, and if it is a .test file, then instead it's going to generate an executable for that file.
So let's talk about this. What were the more popular things? The more popular things, I assume, was to have a separate test directory.
Yes. And after some discussions, I did have it. So there's a test placement section called merged test placement, which is the .test adjacent to the components, and the separate test placement, which is just there's a directory called tests, and you throw stuff in there. There's not really a prescription on that one because it's a lot harder. And I think I'm in of the opinion now that .test is strongly preferable. At least as I've been using it, it's really helpful, especially like when I'm doing code browsing and I look in the IDE, I see, or in the file browser, and I see foo.cpp, and right next to it is foo.test. I don't have to go scrounging around to find where that test actually is.
Well, I like it more for a philosophical reason than maybe the practical ones, which is that it makes test a little bit less of an afterthought. You're really elevating that and saying the module is not done until the tests are written. It's part of the module. And that's, I think, part of what John Lakos is saying, is that if you've written you don't really have a component if you have just a CP file. You need to have the .h as well. And you don't have a component if you just have a header and a implementation file. You need the test as well. You're not done until you've done the test. And I kind of like the fact that those 3 files represent what a component is. And so I'm very sympathetic to this. I can see people looking at it differently, but to me, that's very compelling.
Yeah. So I agree that as I've been doing DDS and specifically with this sort of adjacent test placement, it's really helped like keep them in the forefront of the mind, because as I'm switching back and forth between the two, I can't help but also see that .test there, and I know I better go update that while I'm here. So, and also part of DDS is when you run DDS build, it always runs the test unconditionally every time you build. So you can't forget to run the tests, and you'll know immediately if you've broken a test. But I've now of the opinion that a top level test is still useful, but it shouldn't be like component level unit tests. They should be like the proper integration tests or the acceptance tests that might take a bit longer. And DDS itself has this, so it has .test files for each of the subcomponents, and then it has a directory called tests, which will take the final executable and run it through a whole onslaught of tests that poke all of the functionality. So that's where I am, and that's how I feel about that.
I find a lot of tests are either more cross-cutting, not necessarily integration tests, but just even at a unit test level, you often still need collaborators from different translation units, but also just that there's just not always a one-to-one correspondence between a set of tests and similarly named source files.
Yeah. So it depends on. I guess it depends on. For me, the biggest contributor to how I want to deem a test is not really whether it's a unit of it's a single component, but rather on how fast it is and how quick you get results back. Yeah. So if you
the Mike Lefebvre's definition.
Yeah.
Which
so if
is
you
what?
Run a
Mike Lefebvre's definition of a unit test is a test that runs fast and is repeatable, which usually implies isolated.
Yeah. So I'll put my unit tests, and if I'll make sure they run in under half a second, and if they run any longer, even half a second is pushing it. That's pretty lengthy. And even tests that like touch the file system, I'll still put them in unit tests, but just sort of give them a proper test fixture that can reliably set up and tear down the environment, as long as it takes less than some threshold, like half a second.
Yep, same here.
I think there's some evolution in the history of testing. Initially where testing really was an afterthought is we built an entire app and then gave it to someone else and said, you go test it. So testing was almost always some kind of integration test, some kind of full thing. And then we begin to realize, wait a minute, this is not the way it should be. We should be testing at a lower unit, at the unit level, right? We should test the code as code. And I think that's where the emphasis has been, and that's where it's been, where we've been missing. And now we do have to say that that's not sufficient. Module level testing or unit level testing is something that was sorely lacking. And once we start to do that, then we can step back and say, now, how do we test the application as an application? Because integration testing, you can have perfectly functioning modules and then put them together wrong. You still have failures at that level, right? So all the units are perfect, but we managed to not glue them together in the right way. That we need to test that as well.
Yeah. I got into the industry when TDD was the hot thing. So there was, you test 100% coverage. You need to write your test first. Yeah, all that sort of stuff. And it's sort of relaxed a bit now. We're like, okay, maybe we can sometimes write code without tests first. So can you hear that, cat?
I think the cat has a different opinion. The cat says, no, tests first.
Yeah.
Yeah,
Kids have 9 lives. They can afford it.
that's right.
Mhm.
Our, my background is exactly the opposite. I came from a world where testing was kind of, you make the app and you throw it over the wall, let somebody test it. And they'd send you an email if it didn't work. That was, it was a little bit more, a little better at communication than that. But the point is, testing wasn't integrated the way it was when you came in. And I don't want to see us back away from that. I personally have to work hard to keep testing in mind all the time. It's not intuitive to me. It's not natural to me because that's not how I was trained. That's not how I shouldn't say I was trained. I was pretty much self-taught. That it was not priority when I taught myself programming. Other people weren't hyping on the testing all the time. And if you have that kind of build it with tests in mind, that's great. Let's not lose that. Let's not back away from that. Let's just add to that and say, well, okay, we have high quality components now. How do we test them as a ensemble?
Mm-hmm.
What I think is great about this conversation is we're discussing the details of how we test in specific ways. Whereas years ago, it was, should we test at all?
Right. Well, I don't think anybody thought we shouldn't test. It was just,
You'd be
how important
surprised.
is that? And
throw it to
should
QA.
Yeah. Should engineers waste their time doing testing? Can't we just hire somebody else to do the testing?
Customers.
It's less important. Yeah. Customers. Let them pay us. That's even better. Instead of paying somebody less to do tests, let's get them to pay us to do the testing. That's great. What a great system. Were you about to say something, Colby?
No, I'm just sort of thinking, this idea that there's a tension between whether you test or whether you move fast. But I think if your tests are making it so you can't move fast, you've probably got to change your tests.
Mm-hmm.
It shouldn't take an hour to run to validate a change. If your change, you should be able to test an insignificant change in order of milliseconds, and you should write a test if you need to validate that change.
Well, I think the opposite of moving fast in this case is not the time it takes to run the test. It's the time it takes to write the test. And I've seen this, if you have a lot of test coverage and you go in and you add a new feature, you break a ton of tests, not because you broke the app, but because the tests weren't expecting this new feature. And so a lot of broken tests are false positives in the sense that, well, we need to update the test. And I'm not saying we shouldn't. I'm not giving an argument that, that's a waste of time. I'm not saying any of that. I'm just saying that's a fact of life, that if you're changing functionality, you have to change tests. You may also have to add some new tests. I hope you do. If you're adding new functionality, you should add new tests. But you may also have to change existing tests because the new definition of what the function should do breaks the old tests. Okay, that's fine. And that's what the time is. But I can tell you, and I've seen this a number of times as a new programmer on a project. I used to do contract programming. So I'd be brought in to an existing project and they'd hand me some document, say, this is the feature we want you to put in. And I'm terrified of going in and changing the existing code because there's very poor test coverage. And so I go in and start making changes so that my feature works perfectly, but who knows what I broke because there's poor test coverage. And so that's where you get the speed. It gives you the confidence to say that, and that's what I didn't have. I didn't have confidence because it's like, I'm not sure I can't tell who all's calling this and then wonder what context they're calling this function. And so if I change it, what are the implications of changing this function? And that's what's scary. You have good test coverage. That's what makes you move fast because you just go in and say, oh, I'm going to hack this function. If something breaks, then we know properly how it's used and we can fix it because we have good test coverage. And so that's why I think, good test coverage speeds up development. But you do pay the price to develop that test coverage, right? And that's not.
I find that whether I write the test in parallel to writing the code or whether I write all the code and then write a bunch of tests really affects how tedious it feels. So if I write a whole bunch of code foolishly and not write any tests, and then I get done, I say, I've got to write tests now. And then I spend 10 minutes just like, oh, I don't want to do this. I want to move on to write real code that does real stuff. But if I upfront write, okay, test that I can default construct this, and then make that work. Okay, then test that this method works, and then actually write the method. And I go through that step of lockstep, writing the test, writing the code, back and forth over and over again. It's a lot more satisfying, especially because you can see the progress of the API you're building as you go, because you can actually see the results rather than I hope this works at the end.
Well, and I would hope also, I mean, I've actually done this where I've written an API and then decided, well, I'm going to document how this is used. And then having documented how it's used, I have to go rewrite the API because the use cases, the API is perfect from the inside out. In other words, if you know what you've built, the API makes complete sense. But if you're a user, the API isn't really optimized for you. And so when I tried to document it and say, this is how you'd use it, I realized, oh, this doesn't really work for how you want to use it. And so you go in and change it. And I think if you're writing test coverage, you're closer to writing the use cases, right? You're writing not necessarily the documentation in the sense of explaining why you're using it this way, but you're in fact using it that way. You're saying, okay, this is
documentation.
Yeah, this is in fact what we want to be able to do with this. And you write those cases first. It's kind of like writing the documentation first. It's saying this is what we want to do. And then you build your code to actually perform that way. I think it's a much better way of building code. As I said, it avoids the situation where you get the code working and then realize this isn't really very usable. Recently, I'll dig this up so that so we can put it in the show notes. But recently, Dave Abrahams wrote an article about good libraries, what it takes to write a good library, and the focus really, really is on looking at how it's called, making certain that the names of the library, functions, and classes are such that if you look at how it's used, it makes sense. And that has to make sense. Looking at how people are going to write code that uses your library, if that code makes sense to the user, that's a good library quality. And interestingly enough, most people designing libraries don't even think about it from that point of view. But that's what Dave is arguing. That's the way you should really think about it. What does the code that the user writes look like? Is that easy to read and easy to understand? And if it is, that's a good library. Or at least a good library design. Who knows how badly you implement it or how well, but you designed it well at that point.
Yeah. I find if I'm writing the tests in lockstep and I think this is actually really hard to write the test for it because it's just hard to use. Maybe I should change it so it's easy to write tests for it. And usually I find if it's easy to write tests for, it's probably easy to use. It's probably harder to misuse. Or sometimes I'll keep writing tests and I keep repeating the same line of code over and over and over again, or this whole same block of code over and over again. Maybe I should write a convenience function that does this and add it to the API because it's just so useful. And that's how a lot of convenience APIs seem to come up, at least in my code, is because I was writing tests and I kept copy pasting this 9 lines of code and modifying it. I should put that somewhere that I can actually use it.
Yeah, that should probably be part of the library in some way. Yeah.
Mm-hmm.
So we've somehow pivoted into TDD and library design at the 11th hour.
Well, the 11th hour reminds us we're running long here.
These are great topics, but I think we need to push them to another show.
Mm-hmm.
This is why Robert Ramey says, write the docs first. No, I think that makes so much sense. All right. Thanks for having us on, Colby. You don't mind if I call you Colby instead of Vector?
That's fine. Anyway.
My friends call me Bool. Is that it? You should get a shirt that says that. My friends call me Bool. All right.
Of is my middle name.
Of is my middle name.
Show title.
And most sites don't let you put angle brackets in there in the username.
What narrow-minded people. If it's Unicode, it's a character,
Right.
Why restrict it? All right. Mm-hmm. Well, it's been great having you on, Colby, and we've demasked you or unmasked you or whatever the correct phrase is, and so it won't be a mystery now when people see. What's that?
It's a bit mask.
It's a bit mask.
a dynamic bit set.
Right. So at this point in the show, we want to wish all of our audience safe coding, And thank you very much for being on and for revealing your secret identity. And join me and Phil in wishing everyone safe coding.
Safe coding.
Safe coding, everybody.
Safe coding.